Right, we are still continuing with the introduction to Numpy. So we want to look at now we want to look at the basics of Numpy arrays, the basics of Numpy arrays. So data manipulation in Python is nearly synonymous with Numpy array manipulation. Even newer tools like pandas, which we'll discuss in unit 4, right? Right now we're in unit 3. Pandas will do it in unit 4. Even newer tools like pandas, which we'll discuss in unit 4, they are built around NumPy array. This section will present several examples using NumPy array manipulation to access data and sub-arrays, and to split, to reshape, and join the arrays, right? If you remember, we did the splitting of lists. If you remember this, the way you split lists, the way you create views, copies of lists, is the same way that you do split elements in an array, right? While the types of operations shown here may seem a bit dry and pedantic, they comprise building blocks of many other examples used throughout the book that we're using. Get to know them well, and we'll cover a few categories of basic array manipulations here. So these are the basic array manipulations that we're going to cover. We're going to look at the attributes of an array. What are the attributes of a NumPy array? Right? We're going to determine the size of a NumPy array, the shape of the NumPy array, the memory consumption of the NumPy array, and the data types of NumPy arrays. So these comprise of the attributes that we use to describe arrays. Then we are going to look at indexing of arrays, getting and setting values of individual array elements. You want to get the number of an element, the element of an array using an index, or set the value you want to change in an array. Pana 3, 4, 5. The 5 you want to change it. We're going to look at that. Then slicing of arrays, getting and setting smaller sub-arrays within a larger array. It's like we have a big cake and we want to cut so that we can give everyone, so that they can eat the cake. So we have got several ways that we use to slice. So if you remember how we perform slicing operations in lists, then you're home and dry. This is going to be a joyride for you. But if you don't remember, it's not a problem. We'll cover it. Then reshaping of arrays. When you are talking of shape, patati 3 by 3, that's the shape. 3 rows, 3 columns. Maybe you want to change the shape from 3 by 3 maybe to another different type of shape, from 2 by 2 maybe to 2 by 1 to 1 by 2. That's reshaping. We're going to look at that. Then joining and splitting arrays, combining multiple arrays into one and splitting one array into many. We'll also look at that in this session, right? Right, let's first discuss some useful array attributes. We'll start by defining 3 random arrays: a 1-dimensional array, a 2-dimensional array, and a 3-dimensional array, right? We'll use NumPy's random number generator that we did in the previous section, which we will seed with a set value in order to ensure that the same random values are generated each time this code is run, right? So let me explain this code. Here we are going to import NumPy as an object, which is NP, that we will use to invoke all the functions that we need. Then we set our seed to 0, random seed, so that each time we run the code, we get the same numbers. So the same numbers are generated, right? Then we are going to create these 3 arrays: x1, x2, x3, and this x1, this is going to be our 1-dimension array, right? It's going to be our 1-dimension array, and we are going to generate it through generating random numbers, which are integers. So np.random, np.random, it means we are now generating random numbers, and then rand int, it means the generated random numbers are going to be integers. Then 10 is the number of elements that we're going to generate, and size is going to be 6, right? And kunoku 3 by 4, which means this is we're going to have 3 rows, 4 columns, and here we are going to have 3 rows, 4 columns, 3 dimensions that we're going to have. So right now we are going to run the code. after running the code, we want to discover something here. We are going to try and use three first, and we will navigate throughout the whole arrays that we've created here. So we want to discover the number of dimensions, and we do this by invoking the ndim function. Number of dimensions, n dimensions, ndim. Then the shape will give us the shape of the array. Then size will give us the size of the array, right? So maybe before we do that, we might want to just take a look at a sneak peek to see what the arrays look like. We want to see what the arrays look like. So we're going to print now we are now printing x1, right? x1, which is what? Which is a one-dimensional array. Then let's just copy this code. Here we want to print the x1. Print x1. Now we want to print x2, which is a two-dimensional array. Print x2. Right? Now we want to print x3, which is a what? Which is a three-dimensional array. x3, right? Such that if we run this, you see that x1 is a one-dimensional array, right? This is a one-dimensional array, and in this dimensional array, we randomly generated. We didn't. I made a mistake there. Correct me and forgive me for making that mistake. We are generating numbers from the range 0 to 9, hence the name 10. So we have 10 potential values from which we can generate those numbers. So from 0 to 9, those are the numbers that we're going to be using to generate the elements of the array. And this array is going to be having how many elements here? 6, right? Which is 1, 2, 3, 4, 5, 6. 6 elements. And since it's one dimensional, it means it's one row, right? It's one row, right? It's one dimensional. And then the next one is 3 rows, 4 columns, which is 1, 2, 3 rows and 1, 2, 3, 4 columns, right? And the next number that we have here is going to have what? It's going to have what? 1, 2, 3. Sorry. It's going to have 1, 2, 3, 4, right? 4 rows and 1, 2, 3, 4, 5. 5 columns, right? 4 rows and 5 columns. 4 rows and 5 columns. But what is it that makes it a three-dimensional array? It will become a three-dimensional array because we have 3 sets of 4 rows and 5 columns. We're going to have 3 sets of 4 rows and 5 columns, right? Confusion, so we want to demystify that so that you guys understand, right? And it is now, since now you understood it, this is one dimensional, this is two dimensional, because we have 3 rows and 4 columns, and this is 3 dimensional, because we have 3 sets of 4 rows, 5 columns, which is 1, 2, 3, right? So now what we want to do now is we want to look at the attributes that are used to describe the array that we've just created. So we have this 3-dimensional array, which is x3. So x3 dot dim, it gives us the number of dimensions that we have. So it's 3 here. Then the shape is 3 sets of 4 rows and 5 columns, which is 3, 4, 5. That's the shape. Then we are also going to have what? The size. The size.